Hello, math people. Welcome to day 3 of graphing polynomials. Today we're going to look at imaginary solutions. Remember from the fundamental theorem of algebra that we talked about in the previous video, the degree tells us the number of possible solutions. But a polynomial may also have imaginary solutions. And if you recall from the previous video, imaginary solutions will not intersect the x-axis. The total number of solutions must equal to the degree of the polynomial. And remember, the degree is the highest exponent. And also, this is something new. Imaginary solution must come in pairs. So I can't have just one imaginary solution. I will either have 2 imaginary solutions, or 4, or 6, or 8, or 10, because they have to come in pairs. I cannot have an odd number of imaginary solutions. So between the equation you're given, the function you're given, and the graph, we're going to determine the number of possible solutions, the number of real solutions, and the number of imaginary solutions. What we must remember is the number of real solutions plus the number of imaginary solutions must equal to the number of possible solutions. Okay? So in this equation, y equals x squared plus 2, 2 is my highest exponent. So that means that the number of possible solutions are 2. But when I look at the graph, I see that it never crosses the x-axis. So it does not have any real solutions. So that means it has how many imaginary solutions? It must have 2 imaginary solutions because 2 plus 0 has to equal to 2. And also remember, imaginary solutions come in pairs. So imaginary solutions will not cross the x-axis. All right, let's look at the next one. What is the highest degree of this polynomial? That's right, it is 3. So that means the number of real solutions plus the number of imaginary solutions must equal 3. So how many real solutions do we have? The only real solution we have is here. So we have 1 real solution. That means how many imaginary solutions do we have? That means that we must have 2 imaginary solutions because 2 plus 1 is 3. In our next one, again, this is a cubic. And in this cubic function, how many real solutions do we have? I have 1 here and I have 1 here. So I have 2. How many imaginary solutions do I have? I can't have just 1 imaginary solution. They come in pairs. So I have to have 2 or I have to have 4. But I need it to equal to 3. So how do I get it to do that? Well, I don't have any imaginary solutions, but one of my real solutions has a multiplicity of 2. So I have a solution at, I think that was -5, and a solution at 0, and this solution of 0 has a multiplicity of 2. So that this multiplicity of 2 plus the 1 real that we have would give us a total of 3. I know that's confusing, but we're going to talk about multiplicity in a couple of days. So we have 2 real solutions. We can have a maximum of 3, so one of them has multiplicity. But it can't have an imaginary because imaginary come in pairs. So if we look at this one, what is our highest degree? 4. How many real solutions do we have? 2. So that means how many imaginary solutions do we have? 2. Because 2 plus 2 would give us 4. This is quadratic, so the number of possible solutions is 2. We have only 1, And this one has a multiplicity, though, of 2. How do I know that? Because I can't have an imaginary solution, and the total number of zeros has to equal to 2. And so notice when we have multiplicity is when it bounces on the x-axis. Both of these bounced on the x-axis. Okay? So now we're going to look at this one. Has number of possible solutions is 3. We see it has 2 real. How many imaginary? 0. But notice once again, this one has multiplicity. So that multiplicity is going to help give me those 3 that I need. And again, we're going to talk about multiplicity another day. Okay, so before we do this, I need to remind you of a couple of things. So let's say, for instance, that I multiplied. Let's go back and look at a magic trick here. So I'm going to show you guys a magic trick. If I multiply the square root of 2 times the square root of 2, I multiply what's inside the radical. So I'm going to multiply 2 times 2, and that's going to give me the square root of 4. Well, what is the square root of 4? 2. Let's do another one. If I multiply the square root of 5 times the square root of 5, what do I get? The square root of 25. Well, what's the square root of 25? 5. Do you see the pattern? So if I multiply the square root of 8 times the square root of 8, that's going to give me the square root of 64, which is just 8. So the pattern is this. When I multiply 2 radicals together, the same radical together, the radical disappears and I'm left with the number. Did you see that? Okay? So then I can say radical 6 times radical 6 is simply 6. Radical 256 times radical 256 is just 256. The square root of 1.87952 times the square root of I better write that the same, 7952 is just going to equal to 1.87952 because the radical will disappear. So that's something you need to remember. Also, let's go back to, we talked about this before. By definition, I is the square root of -1. So if I multiply I times I, it's the same as multiplying the square root of 1 times the square root of 1. And what we just figured out, that should also be -1. So I squared is equal to -1. That is something you need to recall. I squared is equal to -1. Okay, so that's a little bit of background of what we need for today. So let's talk about what we're going to do. So up here I just have it. Recall radical A times radical A is A. Radical I times radical I is -1. And imaginary and irrational roots. Irrational roots are going to be written like radical 3 or something like that. Imaginary and irrational roots both come in pairs. So we're going to take I'm going to give you the roots and the degree, and then you're going to be able to write it in factored form and then write it in standard form. That's the goal for this rest of this video. So if I have roots radical 2 and negative radical 2 in factored form, that's going to be x plus, that's going to be x minus the square root of 2 times x plus the square root of 2. Okay? Now, to multiply these together, I'm just going to use a box. So I'm going to, because this is factored form, I want to put it in standard form. So to multiply these together, I have x minus radical 2, x plus radical 2. So recall multiplying these together, x times x is x squared, x times minus radical 2 is minus x radical 2. X times radical 2 is x radical 2. And then radical 2 times radical 2 is going to be negative, because that one's negative, the square root of 4, which is simply 2. So notice these two zero out, And so I'm simply left with x squared minus 2. Okie dokie? Alrighty. I'm going to let you do this one for homework. So I'm not going to finish that one. You're going to do this one for homework. I'm going to go to the next one. And for this one, once again, I'm going to write that as x minus 2i, x plus 2i. So when I write, I'm going to put that in the box. And I have x minus 2i, x plus 2i. So x times x is x squared. X times negative 2i is negative 2xi. This would be positive 2xi. And 2i times negative 2 times 2 is negative 4i squared. Okay, so once again, these middles are going to zero out. So those always zero out. And so I am left with x squared minus 4i squared. Well, what is I squared? We just learned that I squared is negative 1. So this would be x squared minus 4 times negative 1, which is x plus 4. Okay? Again, you're going to do this one for homework. This one's interesting. It has 3 roots. So that means it's x minus 1, x plus 3i, x minus 3i. So I'm going to, I always like to do the i's, the ones with i's and radicals first, because it just makes life easier. So I'm going to do, because that way the i's and the radicals will zero out. So I'm going to have x plus 3i, x minus 3i. So x times x is x squared. Notice that these in the middle keep zeroing out. And negative 3i times 3i would be negative 9i squared. So notice these keep zeroing out. And I am left with x squared minus 9i squared. But remember, I squared is negative 1. So this would be x squared plus 9i, plus 9. Now I'm not done, because now I have to multiply times x minus 1. So once again, putting that in the box, I have x squared and 9 and x minus 1. X and x squared is x cubed. That's 9x. That's negative x squared, and that's negative 9. So I have no like terms, so my answer would be x squared minus, x cubed minus x squared plus 9x minus 9. Okay, let's do one more. And so again, I have 3. You have plus and minus radical 3, and you have 1. So again, I'm going to write this as x minus 1, x plus radical 3, x minus radical 3. And I'm going to multiply these together first. So multiplying these together, I get x radical 3, x minus radical 3. So I get x squared. These middle ones are going to zero out. Those two zero out. And then I'm left with negative radical 9, which is just going to be minus 3. So I get x squared minus 3. Then I have to multiply that times x minus 1. Again, putting that in the box. Next time I do this, I need to give you more space on this. We get x squared minus 3, x minus 1, and we get x cubed minus 3x Uh, then we get negative x squared plus 3. So then the answer is x cubed minus x squared minus 3x plus 3. Okay? Alrighty. And so what you want to do is you want to finish this. The ones that we did not do, you want to finish these for homework. Alright, so here's what we learned from this unit. Is that the number of possible solution must equal to the number of real solutions plus the imaginary solutions. Imaginary solutions and irrational solution come in pairs only. So if I'm not getting the correct answer, like I didn't get for x cubed plus 5x squared, then there's multiplicity involved, which we're going to talk about in the next couple of videos. And then if we're given the roots, we can write it in factored form, and then from factored form we can write it in standard form. Okie dokie, boys and girls.